so we talked about properties of logarithms, right? Logs are those funky things that cancel out exponentials. And there's three very important properties of logarithms that will become a little bit useful when we start solving logarithm equations and stuff like that. So the first property talked about when we see multiplication on the inside of the log, we said that that turned into addition on the outside of the log. So for example, this is just a small one. If you see log 2x, right? Well, multiplication on inside becomes addition on the outside. So it becomes log 2, log x, and then you just add them together. So that's basically what that rule says. There's the quotient property of logarithms, which is kind of the same, but it's with subtraction. So if you see division on the inside, it turns into subtraction on the outside. So for example, if you see log 2 over a, it'd be log 2 minus log a. So it's basically top minus bottom. Finally, there's a property called the power property, which talks about when inside the logarithm, everything is being raised to a power. So for example, if you see log b to the 5th, you can take that 5 and bring it up front. So it'd be 5 log b, right? So I think each of the individual properties are pretty easy. Like you just split up multiplication, division, powers, and all that fun stuff. The problem is when you start piecing them all together, because I feel like a lot of people get confused, like, okay, what do I undo first, right? Do I undo the power? Do I undo the division, multiplication, all that fun stuff? We did a couple examples on Monday where, well, everything was kind of pieced together, and I gave you a couple of hints on what to do. For example, this one, part A, had a bunch of stuff going on, right? We had a power, we had multiplication, and we had division. So we kind of have to choose which one we're going to apply first. Now, I kind of gave you a hint. If you see a power applied to just one term, there's really nothing you can do to it without isolating it by itself, because the 3 here is only attached to the z. So it wouldn't make sense to bring the 3 up front before you've isolated it to the z, right? So same thing with the multiplication, right? There's multiplication here, but it's only between the x and the y. It doesn't concern anything else in the logarithm. So it wouldn't make sense to split up the multiplication because, well, it's not being done to the entire thing. So that's why we split up the division first, because division is happening with everything inside the log. We have this top part divided by that top part. That's why we split up the division first, okay? Once you split it up, then you can split up the multiplication, then you can start looking at the powers, right? So that's kind of how we go about doing it. The other hint that I gave you is if you're subtracting off a log and you split it up into addition, you're going to need to put that result in parentheses because there's something in front of the parentheses, okay? So those were a couple hints that I went over on, I guess, Monday, right? I kind of want to go through part C with you slowly because I think it's a little bit harder than the other two that we've done, just because there's a lot more going on inside the log. So let's start with part C. By the way, anyone walking in need a sheet of notes? I'll have you. I'll just have you. All right. Let's start going over this one. Okay, this is log base A. Don't worry about that it's A and not a number. It's just a variable, right? Of all of this stuff put together. Now, there's a power, there's a square root, there's multiplication, there's division going on first. Well, what do you want to attack first? Do you want to undo the division? Yeah, division is what we want to do first.
For this, if it has like all three, it goes division, multiplication, power. Or is that?
I'm going to say for my class, yes, but I could give you something like, oh gosh, log 3 x times y over z squared, right? Yeah, then you do multiplication first, then you do the power, and then you do division. But I mean, for my class, I'm going to keep it kind of simple. So, I mean, I guess for my class, you can, yeah. For my class, you can think about it division first because I'm probably not going to give you anything else.
But basically, I guess the way you should do it is whatever the entire thing is being done.
Yeah.
Okay.
Yeah. Yeah, but that is a good question. I mean, for my class, I'm not going to be too mean. But in general, it's not just division first. Yeah. Okay. So let's split this up division first. This is log base A of the top, x cubed square root of y, minus log A of the bottom, mz squared. Okay, so I just split up the division into subtraction, and it's looking a little bit nicer already, right? There's not much going on inside each of the logs. Looks like we can do some more. What can I do within each of the logs next? Multiplication, right? Now, it's very tempting to like take the powers like this 3 and bring it up front, but we can't do that yet because the 3 is only attached to the x. So if it's not attached to the entire thing, we can't do the property yet, okay? So let's split up the, the multiplication. So I'm going to split up log a of x cubed y first. This becomes log base a x cubed plus log base a square root of y. Okay, so I just split up that first term into addition. I'm going to do the same thing with the second term. I'm going to write it in orange here. This becomes log base a of m plus log base a of z squared. Did I do something wrong here? Parentheses around the orange, right? Now, this entire log became this expression. I'm subtracting this thing. So if I'm subtracting a full expression, I better put parentheses around that entire expression, okay? Now, oh yeah.
What's the m, the addition of the z?
So whenever you see multiplication on the inside, it turns to addition on the outside. Yeah, gotcha. Now, I don't need parentheses around this guy because there's nothing being done to this, right? There's no negative in front. There's no multiplication in front. So since there's nothing in front of this, I'm actually not going to put brackets or parentheses around this, but I do need parentheses around this guy, okay? All right, couple things I can do here. What should be my next step? Distribute the negative. That's a good one, right? So let me change my color here so we can see what's going on. I have a minus sign, so I can bring it here. I can bring it there. And what we're left with is everything stays the same. Log a x cubed, log a square root of y minus log a m minus log a z squared. Okay, so I just distribute the negative. What else can I do?
The power property.
Yeah, let's do the power property next. Yeah, we'll talk about that second one, but the first and last ones, we can bring the powers up front, right? So this becomes 3 log base a of x plus log base a squared root y, okay, minus log base a of m minus 2 log a of z. Okay, so everything looks all nice, right? All the other logs have just the variables in there. It looks like we're good. There's a little problem with that square root though, right? Looks like maybe we can try to simplify that. Any ideas on what we can do there?
You square both the log and the square root of the square root. I don't think those work.
No, you can only do that if there's like an equation that you do on both sides.
We did the opposite.
You can't, I mean, I wouldn't want to go the opposite direction either. That wouldn't be fun. Let's try rewriting this, okay? I have log base a squared y. Does anyone remember how to write a square root as a power? I think I heard it. Not negative, but I think I heard it. It's 1/2, right? Yeah, isn't the square root the same as the 1/2 power, right? Yeah, there we go. Now we have a power, right? Well, we have a rule about powers. I can take this square, the 1/2, and I can bring that up front, okay? So whenever you see a root going on here, we can still write it as a power and put it up front. So our final answer becomes 3 log ax plus 1/2 log ay minus log am minus 2 log az. And now I don't have anything inside the logs. Everything looks pretty simple. I don't think I can simplify anymore. So looks like this is my final answer. All right. Any questions on this guy? Okay, this one was kind of hard. I'm gonna be honest, I'm probably not gonna ask you something this crazy because there's so much going on here. Um, but I mean, we'll do some more practice on the quiz of expanding out logarithms and making them look nicer. All right, ready to go backwards? Okay, so far we've started with one log and we've expanded it into other logs, right? Well, now what we're gonna do is we're gonna start with something that has a lot of logs and we're gonna work our way backwards to get to one log. Okay, so huh?
Practical application.
Yeah, we'll see one of the applications later on if we have time. Basically that PERT equation, sometimes you need to solve the PERT equation and that's where it comes in. Yeah. All right, let's try to go backwards. I think going backwards is probably more practical than going forwards. Normally we try to condense logs instead of expanding them out. So let's take a look at part A, okay? Here I have log base 7, or sorry, log base 5 of 7. I'm adding it to a half times log base 5 of 5y. I want to condense this into one log. So my final answer should just have one logarithm instead of multiple logarithms together, okay? So now, before I told you that if you saw, let's say, something squared applied to one term, you would wait to the end to do that, right? So I guess maybe the first thing we might want to do is to apply the power property backwards, okay? So I see a 1/2 in front of my log. The opposite direction would be to bring it to the exponent, right? Or square, yeah, square root is a good way to think of it. But let's just do exponents first. Then we can play around with square roots, okay? This becomes log base 5 of 5y to the 1/2.
That's what
That's a good question. Did I do something wrong here?
Yeah, I mean, shouldn't first go around only 5y, because if it's around everything, it won't happen.
Perfect, right? This 1/2, I'm bringing it up to the exponent of the entire thing inside the log. So if I bring the 1/2 just there and I don't write parentheses, then the 1/2 is only being applied to the y. I need the 1/2 to be applied to both the 5 and the y. So instead of writing it like this, I'm going to do 5y to the 1/2 power. Okay, so the entire thing in the log is being raised to the 1/2 power. Does that kind of make sense? Cool. Now, I think Zach just said it, but 1/2 is the square root. So another way you could write this is log base 5 of 7 plus log 5 of the square root of 5, right?
Which makes more sense.
Yeah, I mean, you don't have to do that. You could leave it as the 1/2 power, but I like the look of the square root. I think it looks nice. So I'm going to leave it like that. All right, what else can I do to condense this into one logarithm?
Addition by the 7 square root of 5y.
Perfect, right? Addition on the outside is multiplication on the inside, right? So it's the opposite of what we just said before. So this becomes 1 log, right? And on the inside, I'm going to multiply 7 times the square root of 5y. So we're just going backwards. We're doing the opposite of what the rule says. And well, there's really nothing else I can do here, right? There's no other properties I can apply. So it looks like this is my final answer. All right. Any questions on what I just did on part A? All right, how about this? Part B is very similar, except now we have subtraction going on. So you might want to think about how it might be a little bit different from part A, and we'll come back in a little bit. All right, let's come back up to the front here and go over this one real quick. So Ryan, do you want to take us through your thought process here? Perfect. That's awesome. Very nice job there. I want to talk about one mistake that I saw. I didn't see it in this class, but I did see it in my 8 a.m. class. So basically, when we turn this into log base 2 of 10z minus log base 2 of y to the 4th, I saw a lot of people do this. Okay, they know that there's subtraction and it turns into division, but then they're like, okay, well, I know it's division, so I'm going to write it like this: log base 2 of 10z over log base 2 of y to the 4th. Okay, that's not okay, right? We're trying to condense it into one log, not like write 2 different logs. So this would actually not be correct to write as your final answer, because the division goes on the inside of the log, not on the outside of the log. Okay, I didn't see anyone make that in here, but I saw it a lot in my 8 a.m. So I just wanted to make sure we all knew that. Okay. Any questions on part B? All right, let's do part C. I was going to ask you to do this by yourself, but I do think, oh, you did nice. All right, nice.
I'm pretty sure I did. Because it is
Okay, good. Yeah, it is. Yeah, you got it. All right. I kind of want to go through it slower though. No, that's very impressive. No, that's good. The only reason I was kind of hesitant to ask you this because, well, it's because there's two subtractions going on, right? And when there's two subtractions going on, it's like we have to turn it into two different divisions, which is kind of crazy to think about, right? And we don't really want to do that, okay? When you see something like this where there's two subtractions going on, I'll show you a little trick on how to condense this a little bit easier, okay? And this is the trick. Okay, I'm going to focus on these last two terms. And I kind of noticed that they both have a minus sign in front of it. Okay, so what I'm going to do first is I'm actually going to factor out the minus sign attached to both of those two terms. And this is how I think about it. Okay, we have log base 2 of 560. Okay, I'm going to factor out a minus sign. And whatever goes in here is going to go in my parentheses. Okay. Now, what am I left with if I take log base 27, or sorry, minus log base 27, and I take away the minus sign? What's left? Log base 27, but positive, right? What happens when I take minus log base 25 and I take out the minus sign? Perfect, plus log base 25. And now what I have is I have something that has only one minus sign. And now, well, that makes it easier, right? I don't like it when I'm doing like two divisions in a row. So I think it's a lot easier if there's just one minus sign. Makes it a lot better for us, okay? Now, I can't really turn this into division yet because there's two logs going on here. I need to condense this to one log before I start combining everything together. So, well, there's addition on the outside. What does this turn to on the inside? Multiplication, perfect. So this becomes log base 2 of 560 minus, and this, I guess it's pink, salmon colored, I don't know. This becomes log base 2 of 7 times 5, which is 35. Good. Let me write that out a little bit better then. So we have log base 2 of 560. 7 times 5 is 35. So I'll just leave it like that. Okay. Awesome. By the way, I know I put parentheses around stuff and sometimes I don't. I really didn't need to put the parentheses around the 35, but I just did because I wasn't really thinking. All right. Okay. I have division on the outside. What does that turn into on the inside? Oh, I said it wrong, didn't I? I have subtraction on the outside. I told you the answer turns to division on the inside, right? So this becomes log base 2 of 560 over 35, which is 16. Perfect. This is log base 2 of 16. Perfect. It is 4. Let me just kind of walk us through that though. If I want to know what this number is, I'm really asking myself, well, let's put it into exponential form. Well, what's the base of my exponent? 2. What's the exponent? Well, question mark, right? And what's my final answer? 16. Okay. And what power of 2 gives me 16? 4, right? So this literally becomes my answer. I started out with all of this stuff up top, and using the properties of logarithms, you can actually condense it into a logarithm that you can solve, which is 4, okay? So the properties of logarithms are actually, I mean, I think they're pretty useful because we can start with something like this and it literally just becomes 4. We can't solve these logarithms, but it becomes a pretty easy logarithm at the end. All right. Any questions on log properties, anything like that?
You said like if it's a solvable logarithm like log 2, the final answer won't be like greater than like 5 or something. Right?
Yeah, I'm not gonna give you. Yeah, I'm not gonna give you anything.
Like 1, 2, 3, 4, 5, 6, 7, 8.
Yeah, I wouldn't give you log base 2 of like, I don't even know, like 2 to the 10th power or something like that. That would be crazy. Yeah. Oh, yeah. All right. Well, that's pretty much all I have planned for today, except for the quiz review. So